This is the emerald ash borer. It's a jewel beetle about this big, and although it's beautiful and even kind of cute, this little thing is single-handedly responsible for the mass desecration of millions of North American ash trees across the contiguous United States. But how did this pest come to invade our ecosystems in the first place? Why is it so effective at devastating our local ash trees? And what does the past, present, and future of mitigation efforts look like? My name is Clay, and I'll be telling you everything you need to know about the ongoing environmental catastrophe that is the invasion of the emerald ash borer in America. Informational citations will be in the bottom left-hand corner of the screen, and the video's description will contain a full work cited that will also include the sources for any images used. Let's begin. To start, let's talk a little bit more about the insect itself. Adult emerald ash borers are primarily green, with red or purple coloration of the abdomen beneath their elytra, all of which shows off that beautiful iridescence that is typical of the Buprestidae family. All Buprestids, or jewel beetles, are wood borers. Now, I'm sure you can imagine why something called a wood borer would not be particularly conducive to the health of a tree, but what's interesting is that it's not the adults that are doing the damage here, it's the larva. The EAB lays its eggs on the bark of ash trees. Upon hatching, the larvae will burrow into their host, where they will then spend the course of their 1 to 2 year long lifespan eating through the tree's phloem and vascular cambium, leaving behind serpentine galleries full of sawdust and excrement. They emerge from characteristic D-shaped holes upon reaching adulthood, usually around late spring to early summer depending on the temperature. Here's the thing. Significant disruption of the phloem is a death knell for a tree. The phloem is responsible for transporting all of the things that a tree needs to survive, things like water, nutrients, even pesticides. Inhibiting the phloem's ability to function would be the human equivalent of yoinking out your circulatory system. Needless to say, you don't want that to happen. Now let's take a look at the timeline of events. The emerald ash borer was first discovered in America in Detroit, Michigan in the summer of 2002. After its initial outbreak, the EAB began its rapid spread across the eastern United States. Just recently, in 2022, Oregon joined the list of infected areas, making it the most recent invasion site as well as the EAB's first endeavor into the West Coast. But the fact that we discovered the EAB in 2002 does not necessarily mean that it wasn't here for longer. In fact, it's estimated that the beetle has been present in the United States since the early 90s. We just didn't begin to see its impact until the late 90s, and we were unable to identify it until 2002. The following graphic shows the range expansion of the EAB from 2000 to 2018. The beetle's range expansion exhibited notable changes in speed at 3 points in time, slowing further each time until populations reached saturation in 2015, after which they increased once more. And this graphic utilized a model based on all the available data of the EAB's range expansion to come up with a risk assessment of invasion for the near future. Notice how many of the states that only contain a handful of invaded counties right now have a high likelihood of being more thoroughly invaded by 2030. So, not good. Unlike their Asian counterparts, American ash trees are especially vulnerable to the EAB, since they lack the same coevolutionary relationship with the beetle, and subsequent defenses against them, that Asian ash trees have. The beetles overwhelm our ash trees with sheer numbers, their populations not limited by natural defenses or predators like they are in their native environment. Ash trees can be infested at multiple different life stages, so anything from the sapling stage to maturity is susceptible. A healthy ash tree can be taken out by the EAB in an astonishingly quick 1 to 4 years. Ash trees also contribute to the health of riparian zones. A study of riparian zones in southern Michigan found that a whopping 85% of ash tree basal area in those locations were lost to the emerald ash borer from 2000 to 2017. And to make matters worse, ash tree populations couldn't be reestablished, as seedlings were outcompeted by dense tenacious growths of sedge. Prior to the EAB invasion, ash trees were a staple of riparian forests. They contribute to water quality and soil chemistry, provide shade and temperature control, and lend evapotranspirative properties to riparian ecosystems, so their loss is greatly felt. In addition to their ecological significance, ash trees are also a major timber tree. They're used in the construction for a wide variety of different wooden tools and items, particularly, of all things, baseball bats. They're also regularly used as shade trees in many communities across the United States, and in that regard, they can actually pose a safety hazard, as dead ash trees become brittle and are at risk of falling. Unfortunately, there is no full solution to this outbreak. In the early days of the infestation, eradication may have been feasible, but remember, there's an estimated 10-year gap between the EAB's introduction and its discovery in the United States. By the time we even noticed their presence, it was likely already too late to get rid of them completely, and ultimately, eradication efforts were discontinued by 2006. The real solution was to have never introduced them in the first place. The emerald ash borer is here to stay, and we can now only move forward with actions to mitigate their destruction. And thankfully, we've been doing just that. Systemic pesticide treatments, such as imamectin benzoate, azadirachtin, and imidacloprid, are the most popular method of EAB control. The pesticide is injected into the roots and trunks of healthy ash trees, where the still intact cambium and phloem then distribute it throughout the rest of the tree. Imamectin is effective for 2 years before reapplication is needed, whereas azadirachtin and imidacloprid are typically effective for 1 year and must be reapplied annually. They target the larval stages of the EAB, they're fast-acting, and, unlike broadcast applications, soil and basally applied pesticides, and canopy sprays, systemic treatments have no pesticide drift and minimal negative impact on non-target organisms, allowing for near full coverage of treated trees without causing further harm to the surrounding ecosystem. The downside is that these treatments are often only effective as preventative measures. They must be applied to healthy ash trees, those that are either not yet infested or have no more than 30% crown dieback. In addition, imidacloprid and some other treatments are neonicotinoids, which come with a whole slew of other environmental hazards and concerns, so their use should be carefully considered. Speaking of pesticides, there's been research into the use of endoparasites, such as Tetrastechus planopenisi, as biological pesticides against the EAB. This wasp is the emerald ash borer's natural predator in its native environment. They inject the EAB larva with a venom that inhibits its immune system, and from there, oviposit their eggs directly into the body of the larva. The young wasps develop and eventually burst out of their host, where they then proceed to eat it alive. Other species, like Ubius agrelii, target EAB eggs, consuming the beetle before it can even hatch. These are just 2 of several fascinating and promising species that are being looked into for emerald ash borer control. Another mitigation effort was the enacting of quarantines. Many states enacted county-wide quarantines upon the discovery of the EAB, many of which still exist today, and some of which have even been expanded into statewide quarantines. In 2003, there was a federal quarantine put into place on ash and other related timber products, which was held until it was ultimately deemed ineffectual and removed in 2020. Like it or not, the emerald ash borer is now a permanent part of our country's ecosystems. It has done extensive damage to America's ash trees, and it will continue to do so for the foreseeable future. But there is still hope. Applications of imamectin and azadirachtin are 100% successful as a preventative measure, and where chemical pesticides cannot salvage infested trees, it's looking more and more like our parasitoid friends will be able to pick up the slack. We made this mess, so it's our responsibility to clean it up. Ash may very well become an uncommon sight in America, but at least we can prevent its outright extinction. And that's it.